My name is Robert Moyeda, and I am the meteorologist in charge at the National Weather Service Miami, South Florida Forecast Office, and I will be giving the weather part of the presentation. With me today, here to my right, we have Matahel Ansar. He is the South Florida Water Management District Bureau Chief of Hydrology and Hydraulics, and he will be providing a presentation on the water levels heading into the dry season. And here to my left, we have Major Corey Bell. He's the Deputy Commander for South Florida from the U.S. Army Corps of Engineers, Jacksonville District. So we will be presenting in that order. And afterwards, we will open it up for any questions. Either you want to ask them verbally, or you can also put them on the chat. And actually, I'm already seeing a question. Let me go ahead and the question is this going to be recorded? It is being recorded, and that link will be provided this afternoon after the presentation. So what we'll do now is I will go ahead and kick it off with a quick recap of the wet season that ended last month, and then we will go into the outlook from the weather side for the 2024-2025 dry season. So the dry season began on October 15th. So the South Florida dry season is October 15th to May 15th. And of course, then that's when we switch over to the rainy season, which is a 5-month period. So the dry season, 7 months. The rainy season is 5 months. All right, so we can go over here to the next slide. So just a quick recap of the rainy season, which again ended on October 15th. Most areas in our region in South Florida and even extending up north of Lake Okeechobee, most areas received above normal rainfall, about 10 to 35% of normal. And there really wasn't an extended time frame where we had either a lot of rain or a little bit of rain. We had that the rainy season did start a little bit late, or at least the rains didn't kick in until maybe a week or two after the rainy season began. But we had that rain event in the second week of June, which provided quite a bit of rainfall to much of the region, especially southern portions of the region. So once we got that event in early to mid-June, rainfall was fairly consistent. We had a little bit of a dry period in July, which is fairly typical, and then we in August, September, and October, rainfall was trended slightly above normal, due in part to several of the tropical systems that have affected the state of Florida this hurricane season. And the greatest departures from normal, you see there on the map, especially the areas in dark green, in Southwest Florida, where on average they were about 10 inches above normal for the rainy season. So we're going to now talk about the outlook. So we're looking forward here. So the big part of these outlooks is the phase of the El Nino Southern Oscillation, and we'll talk a little bit more about that. So this year, after being in the El Nino phase for the last dry season, and then that El Nino lasted until about April or May, then we've been starting to slowly transition to La Nina. It's been a relatively slow process of this transitioning over to La Nina, but we still do expect that La Nina will emerge by December. You see there's a 57% chance of that, and is expected to persist through the January-March timeframe. And so that doesn't seem like a long period of time, and in fact, we do expect this La Nina to be shorter in duration than most of the other historical episodes we've had of La Nina, and it's also likely to remain on the weaker side. So we'll talk more about how that could factor into the outlook here over the next few minutes. Just a quick primer on La Nina. La Nina is part of what we call this ENSO, which ENSO stands for El Nino Southern Oscillation, and its counterpart is El Nino. So La Nina is the cold water phase of ENSO. It occurs about every 3 to 7 years on average. It can repeat from one year to the next. In fact, assuming the La Nina does kick in like we expect it to, it'll be the 4th year of the last 5 in which we've had a La Nina pattern in place during the dry season. Before last year's El Nino, we actually had a 3-year period where we had La Nina. So from 2021 to 2023, we had La Ninas, and then we had a El Nino briefly interrupt that pattern in 2023-24, and now we're expected to go back to La Nina for the 2024-2025 season. So these are naturally occurring phenomena that result from interactions between the ocean surface and the atmosphere with the tropical Pacific. So these sea surface temperature changes in the tropical Pacific are a result of wind patterns and precipitation patterns that in turn influence the water temperatures in that part of the Pacific Ocean. So what we want to see is not just a change in the ocean temperatures, but also we want to see what we call atmospheric coupling. In other words, where the atmospheric conditions are responding to those temperature changes of the sea surface there in the tropical Pacific Ocean. So we are starting to see signs of that taking place. This graph shows since 1950 how we've this alternating phase or phases here from El Nino, which are the orange areas there on those graphs, to La Nina, which are the blue areas. So you can see it kind of goes back and forth, but there are some extended periods where we've been in, for example, La Nina, the 2021 to 2023. We've had other extended La Nina episodes as well. And you also see some periods there where we've had El Nino last for more than a year. So these are the trends over the last year or so. So if you go back about a year ago, which is on the left-hand side of those graphs, so these are slices of the tropical Pacific Ocean. So what we're doing here, what this is showing here is the sea surface temperature departures from normal in different sectors of the tropical Pacific Ocean, right near the equator. So on the left-hand side of those graphs, the orange areas are showing where the water temperatures were warmer than normal last year, which was El Nino. And then you see as you go to the right, as you get into 2024, especially towards the summer of 2024, all the way to the current time on the right side of the graph, we've been trending from the orange to the blue, which means waters have cooled in the tropical Pacific and are now running slightly cooler than average, which again leads us to believe that gives us a little bit more confidence that we are headed towards officially declaring this a La Nina probably sometime in the next month or two. So the bar graph on the right, that's from the different forecast models that are forecasting the sea surface temperatures in the tropical Pacific. In other words, giving us an idea which phase we'll be in. And what it's showing is a pretty high likelihood that we'll be in the La Nina. What those blue bars represent is the chances of being in La Nina conditions. So it's showing, again, pretty high chances all the way through the spring of 2025. And then those chances begin to drop off. So once we get past the spring of 25 and maybe head towards next summer, it looks right now, at least very early indications are that we are trending more towards the neutral, which are those gray bars. So neutral simply means neither El Nino or La Nina, kind of in an in-between type of pattern. But it's still early to really speculate beyond this spring. We just really, for now, we're focusing on the what we think the sea state and the ENSO pattern will be for this dry season, which goes all the way until mid-May. So La Nina and El Nino are well known for setting the stage for typical patterns in the jet stream and winds in the upper levels of the atmosphere. So for La Nina during the winter, during the dry season, this is the more typical pattern that we see. It doesn't mean it occurs every single day, but on average, this is the type of pattern that we typically see. So really what we're looking at here is we have the blue arrow that extends kind of from left to right. That's the position of the jet stream. So the jet stream typically separates the cold polar air to the north from the more humid subtropical air to the south. So on average, that jet stream being farther to the north causes the winter storm tracks to pass or to stay well north of Florida, generally following that jet stream, which, as you see there, on average tends to be pretty far to the north across the central and eastern United States. So with those storm tracks being farther north, that usually leads to less moisture and instability in association with fronts that do make it into Florida. In the dry season, most of the rainfall that falls is associated with cold fronts. So if these cold fronts are going to have less moisture and less instability to work with, then usually means less rainfall. And that's why you see there on the map across the southern tier of the United States and Florida, there is a tendency towards drier than normal conditions. So that results in not only drier than normal conditions, but also less storminess during the dry season, which we'll talk more about here in detail. And also so from the temperature side, the jet stream being farther north can lead to fewer or weaker fronts moving into Florida, keeping temperatures generally above normal for longer periods. So the how well established and how strong the La Nina gets is important because that can help to amplify some of the typical patterns that we just described. And it looks like this La Nina, based on these models here, so there's several models that we track that give us an indication of sea surface temperatures for several months out in the future. And it looks like we stay, generally speaking, below in that 0.5 degree below normal range, which is barely into the La Nina category. So as opposed to some other La Ninas, some other recent La Ninas we've had, where we've been a degree or even a degree and a half below normal, this one looks like it's going to stay less than a degree below normal. And again, we're talking here in degrees Celsius. So a weak La Nina would be less likely to result in conventional winter impacts. In other words, the impacts that we described in that last slide. So the factors that we look into for the seasonal forecast are, we just talked about the ENSO phase, or the El Nino Southern Oscillation phase. We also look at what we've seen over the last 10 to 15 years, what we call long-term trends. So for temperatures, we look back at the last 10 years. And for precipitation, we look at the last 15 years. And then finally, we actually have forecast models, both dynamical and statistical models of the atmosphere that can give us projections as well. So we're really using all three in order to come up with the outlook for the season. So we'll start with the combination of the La Nina pattern, right, the ENSO phase, and trends. So when we combine the typical La Nina winter trends, the typical La Nina pattern and what those can lead to with trends, they both point towards warmer than normal conditions in the southeast U.S. and Florida. In fact, you see there on the map there, the average temperature departures when you combine the La Nina composites and the trends indicate a fairly high likelihood of warmer than normal temperatures. So the trends over the last 10 years, in fact, we've had above normal temperatures each of the last 10 winters. So that trend is very difficult to break unless there's a really, really significant change in the pattern. So that combined with the typical La Nina impacts, that's what gives us, that's what's giving this here, and we're showing you here on these maps, above normal, at least a likelihood of above normal temperatures during this winter and really the dry season in general. So this graph shows the trend in this trend that I just talked about. So on the far right is really the last 10 years or so. So you can see where that green line is above the average temperature black line there. So the last 10 years, really almost the last 15 years, we've had warmer than normal winters. So, and in fact, when we look back at all the La Nina episodes we've had since 2000, four of the 30 warmest winters on record in South Florida occurred since 2000 during La Nina episodes. Now, switching over to precipitation, we're pointing more towards drier than normal. And again, so we saw that earlier slide that showed the typical La Nina pattern. when we combine, so this, in this case, the La Nina pattern really is the more dominant signal when it, as opposed to the trend. So when you look at the trends over the last really 10, 15 years, we've kind of been on both sides of average. So we've had some winters where we've been above normal rainfall wise. In fact, we were above normal last winter, but then we've had some other recent winters when we've been either near or a little bit below normal. So there's really not a clear long-term precipitation trend. So therefore, that's where we think La Nina, as well as other shorter duration signals, can play a greater role. And I also went back and looked at the La Nina episodes post-2000. Three of the 30 driest December and April periods on record in South Florida occurred during these La Nina episodes, but also 2 of the 30 wettest. So we've seen a little bit more variability on the precipitation side. So we've looked at 2 of the 3 factors. So the only one that's left now to look at are the forecast models. So the forecast models are all pointing pretty strongly at warmer than normal temperatures during the winter and really extending all the way to April. So that's what you see here on these maps. These are the NMME stands for the North American Multi-Model Ensemble. So it's really an ensemble of all the different long-range models that we look at. So when we combine all those, they're definitely pointing towards above normal temperatures. Then when we look at precipitation, they're giving us a pretty solid indication of below normal precipitation. So warmer and drier for this from now all the way through April. In fact, the models are indicating that it's possible that the February to April period could tilt a little drier than normal compared to the first half, this December to February period. Okay, so we're going to recap this here later on, but before we get to the recap or to the summary of the outlook, I do want to indicate how this relates to specific weather events like tornadoes and severe thunderstorms, as well as flooding rainfall episodes. So I mentioned at the beginning that during La Nina patterns, we tend to have less storminess or less events where we have tornadoes, severe thunderstorms, and heavy rainfall. And in fact, if we look at this graph here, it just breaks down into each of the 8 possible ENSO phases. So we go from, on the right-hand side, weak, moderate, strong El Nino, and then the weak, moderate, and strong La Nina on the left, and then in the middle we have the neutral, where we're in neither of the two. So for tornadoes, there is certainly a tendency for fewer tornadoes during the dry season in South Florida during these weak La Nina and even the neutral events or neutral years. In the past we've had fewer tornado events compared to El Nino, what we had last year, where there's a higher frequency of tornadoes during the El Nino events. But that's not what we're expecting this year, as again, we're expected to be in La Nina. Same thing for strong thunderstorm winds. A lower frequency of those events when we're in the weak La Nina or even in a neutral pattern compared to when we're in a El Nino pattern, when we have, generally speaking, more storms and more storminess during the dry season across Florida. And finally, from the rainfall side, so these are days with 3 inches or more rainfall for different observing locations in South Florida. And again, the tendency is for fewer of those during La Nina and even neutral events compared to, for example, like last year, we were in a strong El Nino. Those number of those events increased quite a bit, and we actually did have some of those events last year. So again, all this is based on past events, and then there's some consistency there with the models, which show which show a fairly good indication of warmer than normal and drier than normal. Now, we always like to point out exceptions. Last year, actually, the the end of the 2022-2023 dry season, when we were in a La Nina, we actually had a pretty stormy period in April where we had, in Palm Beach Gardens, we had an EF2 tornado in April of 2023. We go back to a previous La Nina back in 2016, 2017, we had 3 tornadoes. So just because we're saying less storminess, fewer tornadoes, doesn't mean it's going to be 0. Maybe it will be, but we can't say that with a high level of confidence. There could always be 1 or 2 singular events that could break the overall trend. So singular events can occur in any season, in any ENSO state. So what we're looking at here is we're looking at a general longer-term average. Also, in that right at the tail end of that 2022-2023 dry season, we also had that severe Fort Lauderdale flood again in April of that month. So again, this underscores it doesn't mean that we're going to have 0 flood, 0 tornado events. It just means, on average, we tend to have fewer of those when we're in the La Nina phase during the dry season. So bringing it together here to the outlook. So this is the outlook that the NOAA Climate Prediction Center came up with back last month, and it's going to be updated actually this week, but we're expecting it to be pretty much the same. So from a precipitation standpoint, it's calling for the likelihood of below normal precipitation, maybe a little bit tilting more towards below normal from Lake Okeechobee northward, but still all South Florida at least has a reasonable chance of seeing a below normal precipitation. This is for December to February, but the outlook for February to April is virtually the same. So if I showed the map for that February to April period, it would look almost exactly the same. From a temperature standpoint, again, tilting, leaning towards above normal temperatures, and that includes really almost the entire southern tier of the United States, going all the way up into the eastern seaboard. And again, this is the December to February. February to April one looks almost the same. So I just decided to show one to represent really the entire dry season. So to summarize the La Nina influence, La Nina sets the stage. It's not a cause. It is tempting to say, yes, La Nina is causing this drier than normal pattern, or La Nina is causing this warmer than normal pattern, but it's not a direct one-to-one relationship. It sets the stage for these weather patterns to be in place that then lead to those conditions. There are other patterns, and this is where we go back into the exceptions again. There are other patterns that can influence or even dominate for periods of time during a particular season. And there's these different oscillations that we call there's the North Atlantic oscillation, the Arctic oscillation, Pacific North American pattern, and the Madden-Julian oscillation. There's actually a few more out there, which we could probably spend a good hour just talking about those. But just in summary, these are shorter duration cycles that are really hard to predict more than a couple of weeks out in advance, but they can temporarily either enhance the ENSO phase or multiply, if you will, that typical ENSO pattern, or it can actually counteract it at times. So we have to keep an eye on that as well. And when we're in a weaker La Nina pattern like we're expecting, those other cycles can have a bit more influence. So we do have to watch out for that as well. So when we talk about these outlooks, we often refer to them in terms of probability. So in other words, there's a 60% chance of above normal temperatures. Well, what does that mean? Well, it means that there is a 60% chance of above normal temperatures, of course, but it also means that there's a 33.3% chance of it being near normal temperatures. So it's about a 1 in 3 chance. And that only leaves us with the third outcome, which is below normal temperatures. And that one only has a 6.7% chance, so really a less than 1 in 10 chance of below normal temperatures. So it's important to consider that the outlooks show the most likely outcome, but it's not the only possible outcome. Similarly, if we look at the precipitation chances, let's say they're 50%, that means that there's a 50% chance of below normal precipitation. but there's also a 33% chance of above normal, of near normal, which is about, again, 1 in 3, and then about a 1 in 6 chance, or a 16.7% chance of above normal precipitation. So it's not a slam dunk that we're going to be above normal temperatures or below normal precipitation. We're certainly leaning that way, but again, we have to consider that that's not the only possible outcome. So this is the summary of for different elements: temperature, precipitation, storminess, chances of freeze, and drought and wildfires. What we're looking at as far as the outlook for this dry season. So temperatures, again, the most likely outcome is above normal, in the probable 1 to 3 degree Fahrenheit range. Precipitation, below normal, probable range about 10 to 30% below normal rainfall. Again, this goes from December to April, what's left of the dry season. Storminess or severe weather episodes, below normal number. But again, we're saying probably somewhere in the 3 to 5 episodes range. So that doesn't mean 0. It means we will likely have a few, but a little bit lower than the average for a dry season. Drought and wildfire. Most dry seasons, we end up going into moderate drought, at least at some point during the dry season. So I would say the chances are near normal that we'll eventually end up in some kind of drought condition, especially, we're more likely during the second half of the dry season. And finally, freeze. This one's may seem a little bit more counterintuitive. We're saying there's a near normal chance of a freeze. So even though we are forecasting the likelihood of above normal temperatures, these breaks in the pattern that can sometimes lead to intrusions of Arctic air deep into the southern United States can give us the opportunity for 1 or even 2 freeze events in any season, even if we're in a pattern like La Nina, where we end up trending above normal temperature-wise. So these values represent average conditions across the entire region of South Florida. Individual locations or individual points can see higher or lower values. So this summarizes what we just talked about. Confidence in general, I would say, is moderate to high. We don't want to say it's high for every single one. We do want to open up always the possibility, as we mentioned in the last slide, that that things could end up averaging out a little bit higher or lower, especially in specific locations. So the seasonal outlooks are really just what that term outlook means. It means a general big picture view of a set of conditions that will probably exist in the future. So that's straight out of the dictionary there. So that's why these outlooks are associated with a large degree of uncertainty with regards to specifics. And they're, again, average conditions over the course of an entire season, not representative of what is expected each and every day. And even during a relatively well-established pattern, there can be week-to-week or even month-to-month variation from the normal. And that's something that we should expect at some point during the season. So really, at the end of the day, these outlooks are useful for general planning and overall awareness, not necessarily to forecast what weather is expected on a certain day, let's say 2 months from now. So as far as impacts from a La Nina winter, really the one of the main things that we look for, or that we look at, is the possibility or even the likelihood of extended dry periods. And these extended dry periods can lead to drought conditions, which of course can affect our water supply. And that also can lead to a higher threat of drought and wildfires, especially during that second half of the dry season, which is when our fire season here in Florida. And again, I talked about the chance of freezes, even with fewer intrusions of Arctic air. So when we have these longer warm periods, it can make the crops more sensitive to cold outbreaks that can still occur. So that's something I know that our agricultural interests keep a pretty close eye on. Rip currents can be enhanced. In fact, we've seen a pretty extended period of onshore east winds in the southeast coast of Florida, which have led to several rip current episodes already this month. And that's we expect that probably to linger and then also come back or return more likely in the springtime when we start getting the easterly wind pattern come back. For freeze and cold temperatures, the typical time frame for that is December to February, the winter months. Severe weather, it can happen anytime during the dry season, but it tends to be more. It tends to happen more during the second half of the dry season, let's say from February through May, and also that February to May time frame. That's when we typically have more of the wildfires and droughts across the area. All right, so that concludes the weather side of the outlook. So now we're going to transition over to the water side. So I'm gonna pass it over here to Matahel from the South Florida Water Management District, and he will talk about the outlook from the water supply standpoint. So.
Hey, good morning. Matahel Ansar, Bureau Chief for Hydrology and Hydraulics, and I'm going to give you a water condition update and what we are doing to prepare for the dry season. So I'll start with the rainfall, just to reiterate some of the things that Robert was mentioning. The wet season, obviously, as Robert showed, was above normal, 120% normal. And what I'm showing there is basically a month-to-month variation of rainfall. Anytime you see a dark blue there, that's a surplus of rainfall on that month. When you see a red, I mean we had a deficit compared to the normal for that month. And what you see, again, focusing on the wet season, the total rainfall was about 120% of normal. Again, the wet season was between May 13 and October 9th, 2024. May and July were below normal. That's where you see those red there. June finished above 90th percentile, and August was near normal. June had a lot of rain, up to 4.62 inches above normal. That's when we had that low pressure system that dumped a lot of rain, mainly in South Florida. As far as the dry season itself, it started October 10th, 2024. So far, October is 120% normal, but La Nina conditions are expected to develop, as Robert mentioned. That should lead to some drier than normal conditions. I know Robert already showed a graph to the left. That's just to reiterate basin by basin. All those basins are showing above normal, anywhere between 7% to 135% above normal. And then so far, November is showing below normal. That's the graph to your right. You see a lot of khaki color there. The darker that khaki color is, the drier the conditions are in those basins. Some basins experiencing anywhere between 20 to 50% of normal, and the rest are below normal. November is 88% of average. Again, few basins are normal or below or above normal. The rest is below normal, as shown by those khaki color there again. Now I'm going to start talking about the regulation schedule and the water levels in the different lakes and water bodies. Normally what we do is we compare our stages in those lakes to a regulation schedule. A regulation schedule is shown in red in all those graphics. Essentially what a regulation schedule is, a time varying line that typically will dip somewhere in March and then reach its lowest point by June 1st. The idea behind that is to build storage in those water bodies before the wet season comes. And then as we start getting rain during the wet season, that water body or that lake start filling up. And the end objective is really to get those lakes at what we call the winter pool, which is the highest point of a regulation schedule. And what you see in all of this graph is all our water body lakes are right at winter pool or very close to it, which is a good thing for water supply. Just basically mean the system has refilled to the way we expected it to, and we are ready for the dry season. And the regulation schedule is also a tool that really help us figure out what type of operation we need to have. When we are above it, we're typically doing flood control operation, meaning we are moving water and we move it as safely as we can to provide flood relief to upstream basin. When we are below it, we're typically in water supply operation. And those water supply operation could be for consumptive use. They could be water supply for ag. They could also be water supply for the environment. When we're doing ecological flows, say to Everglades National Park, those are water supply to the environments. In any case, starting with the lakes to the north, this is East Toho. You can see that it's right at Winter Pool. Lake Toho is also at Winter Pool. And then Lake Kissimmee is slightly below schedule, but very, very close to it. Lake Istopoga, which is just northwest of the city of Okeechobee, it's also at Winter Pool. You can see that there. Again, meaning it's really where it needs to be for this time of the year. I'm gonna skip this, as I think Robert already covered La Nina discussion. Just show that La Nina conditions are expected to develop, although it's going to be a weak La Nina, it looks like. But why are we paying attention to La Nina? Typically, when La Nina condition develop, typically Lake Okeechobee would show a downward trend. What I'm showing there is basically a series of years where we had La Nina condition, and all of these years you're going to see that a downward trend in Lake O levels. Very few of them show anything where the stages are increasing. Typically, they're going down, and luckily, again, Lake O is in great shape. It's at 16 and change, 16 feet NGVD and change. I'll show that in a second. It's at 1609 last week. I think this week, I just checked it this morning, is at 1605. So it's just starting to dip a little bit. And what it shows there is basically Lake O level compared to other similar years. You can see that it's high, but not terribly high. It's on the high side, maybe around the 75 percentile. What that means is basically we have a good amount of water for the dry season. Lake O is the liquid heart of a system, obviously. It's our biggest storage, I think, for this type of stages. It has close to 3.5 million to 4 million acre feet of water. So it has more storage than all the 3 WCA water conservation area combined. So that's really a good thing when we have Lake O this high into the dry season. It just means we should be in good shape as far as water supply. Another thing we do is we run regional models. We run the South Florida Water Management Model. It's a 2x2 model, meaning we run it on a 2 miles by 2 mile grid. What it does, it take rainfall, historical rainfall as input, all 40 plus years of rainfall with current operation and current infrastructure, and simulate what Lake O levels may be under those different rainfall events. And then those results are basically used to generate statistics and generate what we call a position analysis, which is what I'm showing there. Essentially what it shows is where the Lake O level might go to in the next few months. It goes all the way to the next wet season. And typically what we pay a lot of attention to is this pink band area. That's where Lake O is between the 25 percentile and the 75 percentile. That's the area that has the highest likelihood of Lake O following. What it's showing is there's 50% chance that Lake Okeechobee level will fall into that pinkish region, which is great. That's zone D. That's really a sweet spot. We are somewhere between 13 and 15 and a half or so, which mean in those stages we don't have too high of water in Lake O for flood control, or we also don't have a water supply concern. So that's great. On the other hand, you have some extreme that could happen. Again, as Robert pointed out and stressed, those could happen, but they have very small likelihood, a small chance that we may go into a drought condition, but that's not till July, August timeframe, maybe a 5% chance of or so of that happening. On the other end of the spectrum, there is also about 5% chance that we could go into that higher level there in zone BC. But again, those are very small chances of that happening. With a weak La Nina, like Robert mentioned, if that materializes, the likelihood of us again following that pinkish region is very high. Why? What is La Nina and why do we care? So I think Robert already explained a lot about La Nina. But from our perspective in hydrology, the reason we pay a lot of attention to it is it increases the chances when we have El Nino. That increases the chances of wetter than normal dry season, and I think Robert explained that a lot. And then also with La Nina, that increases the chances of drier than normal dry season, meaning drier than your typical dry season. In general, November through March rainfall is expected to be 140% during normal El Nino years, and then 85% of normal during neutral condition, and 60 to 65% normal for La Nina. ENSO conditions are a big determinant in Lake Okeechobee net inflow during dry season. What that means is Lake Okeechobee levels are sensitive to those ENSO conditions. What I'm showing on the left there is basically what happened during ENSO El Nino year versus La Nina year. In El Nino year, we see a positive net inflow, meaning we expect Lake Okeechobee to go up. That's shown in red there from November to April. On the other hand, during La Nina year, we have a negative net inflow to Lake O, and that means basically we expect a downward trend in lake stages as it's losing water as opposed to gaining water if La Nina condition materialize. Another thing we looked at also during, I know this is a pretty busy plot, but what it's showing is that index that Robert was showing, that Nino 3.4 anomaly is a 3-month center moving average. When it's negative up to minus 0.5 from normal or beyond, we are in a La Nina condition. When we are above, we are in El Nino. And again, as Robert mentioned, we're expecting a weak La Nina, close to that minus 0.5 deviation from normal. When that happens, we see a strong correlation with what's happening with Lake O. We're seeing this is a net inflow November, April in feet from in Lake O. Again, during La Nina year, you're seeing negative, meaning some decreases in Lake O level. An example, strong La Nina happened in the early 70s, 73, 74. There was a net drop of 1.7 foot. We don't expect that to happen this year because now it doesn't look like we're going to have a strong La Nina, but with a weak La Nina, we certainly expect some drop, not as high as 1.7, but probably in a few tenths of a foot, at least from the La Nina condition itself. Of course, there are other factors that may make Lake O dip deeper, but what I'm showing on this plot is all La Nina years, meaning those drier than normal condition during the dry season. Again, you're seeing that downward trend. This is a different year, repeating that position analysis, just focusing on those La Nina year. Again, because it's a weak La Nina, the likelihood is we're going to be falling most likely the red line there if the weak La Nina condition materialize. It's similar to what I showed earlier, except this is a subsampling, just focusing, like I said, on those drier than normal dry season. Now moving south, Lake Okeechobee itself, U.S. Army Corps of Engineers obviously operates the main structure from Lake O, and Major Bell will talk to you some more about that. But what we're seeing there is, at least for this week, LOSUM release guidance is showing no release for S80 up to 300 CFS at S271, that's L8 canal, and then up to 2,000 CFS at S79 and up to 1,100 CFS at S351, 354 combined. Those are discharges to the south into Miami Canal and North New River and Hillsborough. And what we're seeing with the water conservation area is WCA1 is slightly below schedule. WCA2 and 3 are above schedule. That's 2 there, and this is 3. Because WCA1 is below schedule, the Corps has the S10 structure closed. Those are the structure between WCA1 and WCA2. And then they have the S11 open, and then S12, B, C, D are open, sending water to Everglades National Park. S333 and 33N, those are structures that discharge into L29. Those are also discharging, sending water to Shark River Slough. There are water supply operation happening in South Dade Conveyance System, and also S199, S200 pump station, and S332 D and C are making releases as needed, sending water to Taylor Slough. We also look at groundwater. What I'm showing there on the map is basically the groundwater well monthly stages compared to historical monthly stages, doing statistics on those, and the reds are basically when you are in the lowest 10 percentile. The orange is 10 to 24 percentile. The The green is 25 to 75, and then blue is 75 to 90, and then black is 90. So for this time of the year, what we really want to see on that map is a lot of black, a lot of blue, and maybe some green, essentially meaning the water in those groundwater wells are in the upper end of the spectrum, and that's what we're seeing. In Upper Kissimmee, we see a lot of blacks and blues and some green. Same thing in the Upper East Coast and Lower East Coast, just showing that the groundwater is in good shape as well, just like the surface water. We are seeing some isolated red on the West Coast. Those are deeper aquifer that take some time to recharge, so we expect those colors to be more favorable in the next few months to come, but that's something that typically happens when you have a very deep aquifer that take longer to recharge. But in a nutshell, both surface water and groundwater are in great shape for this time of the year. We also look at the drought monitor that's produced by U.S. Department of Agriculture. As you can see, none of the area that we cover is in any drought condition, which is a great thing. There are some drought conditions in North Florida and Northwest Florida area, but that's outside our region that we cover. So what do we do during this transition to dry season operation? Typically, we'll check and test forward pumps. Those are pumps that we will install by Lake Okeechobee when gravity is reduced. As you know, water that we take from Lake O to the south is mainly by gravity. So when Lake O get too low, we have sometimes difficulty getting that water out of the lake. To compensate for that, we have to have pumps that will actually pump water out of the lake into those canal systems. So normally this time of the year, we'll go ahead and check and test those forward pumps, which we have done, just to make sure in case, in the slim chance that we get into a drought, we are ready and we will be able to get water out of Lake O under very low lake stages. We also schedule maintenance and upgrade activities. We switch from flood control to water conserving strategy. We switch canal operation to high range, meaning we maintain those canal higher. And that high end, typically what it does is it help the nearby groundwater, and it will prevent or limit saltwater intrusion in some of those wells that the cities depend on for their water supply. We track rainfall accumulation and projection. We manage water and storage to last us through the dry season while satisfying the system need. And that's what I have. I don't know if you have any question for me.
We'll transition over now to Major Bell, and then we'll open it up for any questions and comments. All right. So now joining us will be Major Corey Bell from the U.S. Army Corps of Engineers, Jacksonville District.
Awesome, thank you, sir. Major Corey Bell, Deputy Commander for South Florida in the Palm Beach Gardens office. So we kind of touched on a lot of information here on outlooks and forecast. But today, the Lake Okeechobee is sitting at 16.05 feet. We continue within Zone D of LOSIM, that's the Lake Okeechobee System Operating Manual. And we continue to do our target releases to S79 at 2,000 CFS and 0 to the east through S80. The C44 is currently sitting at 8.66 feet. And only the S404 structure there is released about 12 CFS, and that's mainly due to local rain fall over that system. The WCAs, as briefed, are continuing to recede, and we're watching those. And then as we move forward in the dry season, we're looking at Lake Co recovery operations, and we will communicate that with our stakeholders and community once a decision is made. And then at the earliest that would be taking effect would be the end of first week of December. So that's all I have. So we can move to questions.
All right, thank you very much, Major Bell, and then thank you, Matt Hell, also for your presentation. So now we will open up the line for questions. What we'll do is I will put this earpiece on, so I'll be able to hear questions. So you can ask questions just by unmuting your device, or you can also type it in on the chat. And in fact, we've already seen a couple of questions here. So I'm going to address the ones that I see here on the chat first. So. One question is here under LOSIM. Is there a general guideline on preferred lake levels, such as the 12.5 to 15.5 feet that we used, or that we use under other? Would you like to address that, or is that?
Yeah, so we're not targeting anything specific on 1 June. I know folks want to know a number. We kind of look at the atmospheric conditions and the environmental conditions. But if we initiate the Lake O recovery operations, we have a target goal, which is 12 feet, 12 feet for 90 days or 11.5 for 60 days. So when we initiate those operations, that's our targets. But it's if there's a point where we believe we're going to fall below those from a water supply standpoint, we can always stop and cease Lake O recovery operations to see what the environmental conditions. As discussed, if you watch our website, you can see natural recession right now in Lake Okeechobee, but we're very positive that we can meet our targets for lake recovery operations.
All right, thank you very much. We have another question. How is South Florida Water Management District feeling about Mid-Hawthorne at this point?
Yeah, I think that was showing some of those colors in orange, some in red. Like I mentioned, that's an aquifer system that take longer to recharge. Obviously, we would like to be doing better than what is showing there right now, but we're not terribly concerned about it because, as I mentioned earlier, it takes longer to recharge. Ideally, it would be in a green or blue color, but right now I believe most of them are orange with some reds there.
All right, and then we have another question. I think this might be the last question, at least from the text, from the chat for now. Can we explain the mechanics of a freeze occurring during a La Nina phase? And it's similar to what it is, and when we get freezes in South Florida in general, is when we have a dip in the jet stream. So the jet stream is this river current of air. Usually about 35,000 feet above the surface, and it generally it outlines the storm track. In other words, these tracks of these winter type storms that move west to east across North America, and it also tends to separate the colder continental Arctic air to the north from the warmer oceanic or even tropical air that could still linger to the south. So when we have these dips in the jet stream, by dips I mean when the jet stream shifts farther to the south across the eastern United States, sometimes that jet stream can make it all the way down into the Gulf of Mexico and even Florida. So that's when we can get not only these stronger cold fronts associated with these storms moving into Florida, but also the air behind these cold fronts can be more of a continental or even Arctic in origin. In other words, coming straight down from northern Canada. And that's what can give us these episodes of cold, these cold episodes and even freezing temperatures across the region. So we think during La Nina episodes, these don't happen as frequently, but they still can occur. And in fact, they have occurred in past La Nina events. So I think that's kind of a brief, as brief as I can mention it, without getting too long as far as what the mechanics are as far as how we can get these freezing temperatures or these cold episodes down into Florida. Okay, I'm going to give an opportunity. Is there anyone who wants to ask a question just by unmuting your device? I have an earpiece, so I'm able to hear any questions that come in. I want to give an opportunity in the last about 5-7 minutes that we have for anyone who wants to ask a question verbally. I do have a couple of other questions here on the chats, but I want to make sure. Are there any questions that anyone wants to ask directly that I can hear here on the earpiece? Okay, well, maybe people have some time to think about a question that they want to ask. I have one more question here. Why has La Nina been so hard to pin down this year? At first, we thought it would emerge in the summer and then early fall, now possibly December. Well, not every event is as easy to predict. I think we've gotten used to some fairly, I would say, for lack of a better term, or fairly easy events, in a sense that, the pretty well-defined events. And I think we've had several more of those in the last, let's say, maybe 5 to 10 years. But I can remember many times in the past when we've had where the signals have not been as well-defined. So I think, this could be one of these years where we have been slowly getting to La Nina, but it hasn't been a really rapid, we haven't gotten there rapidly. So that's why, it's been slower in developing. And there could be multiple reasons for that, which really are hard to pin down or to attribute it to one primary cause. But I think in general, though, we have been leaning slowly in that direction, but I think that also lends more confidence to the likelihood that this La Nina event will be shorter duration, I should say, and probably not as strong as the last few that we've had over the last several years. Okay, we got another question here. Does LOSM give the Corps any additional flexibility for managing the lake during La Nina conditions?
So I can't speak specifically towards the weather condition, but if the triggers are in a place right now where we can initiate recovery operations, and again, the recovery operations is a focus on the lake's ecology, so that's to allow the lake to recede on a natural slope and to allow the subaquatic vegetation to grow, which naturally filters waters from the Kissimmee chain. So that's kind of the purpose, but we don't have specific, I don't know if the specific indicators based on the conditions. For lake recovery operations, it's clearly defined, but I don't have the water control plan memorized to that level.
So yeah, that's why one of the things I made. Again, I'm not an expert on the water manager side, but as you saw, Matahel showed he showed that one graph which showed the range of possible levels here, and that's why it's always important that we don't focus on only one possible outcome, not only from the atmospheric side, which is what I described at the beginning, but also from the water side. So understanding that there could very well be some exceptions, and we've seen that in the past. While again, we could have a general state of conditions that could last for, let's say, maybe 5 of the 7 months of the dry season. When you get those breaks, even in a short duration break, if you will, let's say a break of a month or so, that could be enough to significantly change or to affect the final outcome of what we end up getting. So that's why, again, we're dealing here in the realm of probabilities. We're dealing in the realm of possible outcomes. And I think, again, that's why these outlooks can be useful from a planning standpoint, as long as we understand, and we do understand, that that's how we apply these outlooks for managing water levels really over a 7-month period, all the way until we get to the next rainy season. Okay, another question here. Is the U.S. Army Corps of Engineers taking into consideration the fact that the St. Lucie estuary has been oversaturated by stormwater runoff when considering drawdown under Lake O recovery ops? Major Bell?
Sure. So if we were to move forward on lake recovery operations, so the total inflow into the St. Lucie estuary will not exceed the 1,400 CFS, which is within the non-harmful range of releases. So it's not only S80, we have to look at other structures within that basin, specifically C23, 24, and 10 Mile Creek. So there's things we have to look at and balance, but the objective is to keep that within the normal range, non-harmful release schedule.
All right, thank you very much. Yeah, we got some good questions. We still got a couple minutes left here, so keep them coming. Also, again, if you want to ask a question verbally, I should be able to hear it, so feel free to do so. I want to take this opportunity to thank the South Florida Water Management District for their hospitality in hosting the dry season outlook. Of course, also with Matahel for his presentation, and also the U.S. Army Corps of Engineers. I want to thank them as well. They first joined us for this outlook back in May when we did the wet season outlook, and we're glad to have Major Bell again with us for the dry season outlook, and we hope we can make this, we can continue this for the outlooks here coming up in the future. So again, taking one last look here. So, okay, it looks like this might be it for questions. So we will make this presentation. This has been recorded, so we will send out the link for that at some point. If not, if you don't get it this afternoon, we will certainly have it in the next day or so. We will try to get these slides out, both my slides and Matahel's slides. We'll try to get those out to everyone by later this afternoon. If you have any questions, there will be some contact information on those slides that you can reach out for additional information. So once again, on behalf of Matahel and Major Bell and the South Florida Water Management District and the U.S. Army Corps of Engineers, I thank you very much for your participation, and have a good rest of your day.